Let's do a simple projectile motion problem involving a soccer ball. The soccer ball is going to be kicked towards the goal 24 meters away, and we'd like the soccer ball to clear the height of a goalkeeper who can jump to a height of 3 meters. So the first thing we want to consider is how far will this go, how high it will go, and will it in fact clear the goalkeeper. The key to projectile motion is understanding the force diagram. In this case, at the very top of the flight, or anywhere along the flight, there's only one force. It's the force of gravity. And in the XY, traditional XY direction, it's acting in the Y direction. So we can use any one of these three constant acceleration formulas. They only work if acceleration is constant, but that is the case in the Y direction due to gravity. So we're taking little g here to be 9.8 meters per second. It's really going to be negative since we're kicking the ball upward. Gravity's tending to bring it downward. So we want to break the initial 15 meter per second velocity into x and y components. In red, I'm showing the x component, and that will stay the same the entire way because there is no force in the x direction. But look at what's happening to the blue component, or the y component. It gets smaller and smaller as gravity is pushing it down. In fact, the y component is going to get to be 0 at the top of the flight. And when we look at the resultant vectors all along, you can see that it's responsible for the parabolic shape. So we want to break the 15 meter per second velocity into x and y components using the 50-degree angle. And so we're going to need to use sine and cosine. The x component is going to be 15 cosine of 50 degrees. And anytime you have a cosine component, you're going to have a sine component. So the y component will be 15 times the sine of 50 degrees. And so just adding the numbers, we have 9.64 meters per second in the x direction. That'll stay constant. And the y component will be 11.49 meters per second initially, but that will, of course, be changing. So first, to find the height, let's kind of zero in on this formula. And we're going to realize that in the y direction, the displacement is really height. And the final velocity in the y direction, as we noted earlier, is 0. So doing just a little bit of math, plugging into the formula, we're going to take that final velocity to 0. The initial velocity, which will square, will be 11.49 meters per second. And we'll add 2 times the acceleration, which is the negative 9.8. And again, it's negative because our y direction, if we're taking our y direction up as positive, then the gravitational effect has to be negative. And our displacement is what we're calling h. And we're coming up with h to be a height of 6.74 meters. To find the range, or the displacement the ball is going to take in the x direction, we're going to use the displacement formula. And we're going to use the initial velocity of 9.64, and we're going to cross out the acceleration because there's no acceleration in the x direction, only this 9.8, this gravitational acceleration in the y direction. So we're going to set up the displacement to be equal to 9.64 times the time. Now we don't know time just yet, but we can find time using this other formula, final velocity equals initial velocity plus acceleration times time, in the y direction, because it is the y direction, or the gravitational direction, that is in fact controlling how long this ball is in the air. So considering once again the velocity at the top to be 0, we're going to use the 11.49 initial velocity, and we're going to use once again, acceleration to be a negative 9.8. And we're going to find the time for half the flight to be 0.173 seconds, or 1.173 seconds. And again, that's the time for half the trip. So if we wanted to find the time for the whole trip, we would just simply double it. It is symmetric. It's symmetric because gravity's having the same effect on the way up as on the way down. So if we plug in that time for their displacement formula, we'll find that the displacement to go halfway is 11.31 meters. And we would just need to double that to realize that it is going to be about 22.62 meters. So we think that the ball will just land in front of the goal and probably will just bounce into the goal, 22.62 meters, but will it clear the goalkeeper? And to find out, we're once again going to use the displacement formula. We're going to take advantage of the fact that it's the same time for both the x direction and the y direction. We're going to find time in the x direction because we know the displacement in the x direction. It's 18 meters, the 24 minus the 6 meters. And just using the 9.64 initial velocity and an acceleration of 0 in the x direction, the time in the x direction is 1.867 seconds. But that's got to be the same time in the y direction. So that's the time it took the ball to get to the plane of the goalkeeper. Now when we apply that in the y direction, that'll tell us the height the ball is when it reaches the plane of the goalkeeper. And so we just apply the same formula in the y direction. Now we do have an acceleration term. It's going to be the negative 9.8 because of the acceleration due to gravity. Times that same time, we have to square the time. When we do this, we find the final height is going to be 4.37 meters, which is indicating that we are going to score a goal because the goalie can only jump to a height of 3 meters. So thanks for watching. Don't forget to subscribe. We'll see you next time.